In the study of three-dimensional geometry, understanding how a surface is oriented at any given point is essential. This cohesive narrative explores the relationship between mathematical theory and geometric form. Orientation is defined by a direction pointing straight away from the surface, known as the normal vector. There are two primary ways to identify this direction. One way is by looking at the flat, tangent directions that sit perfectly against the surface and finding the one line that is perpendicular to them. Alternatively, the gradient serves as a mathematical compass that always points in the direction of the steepest ascent from any point. A critical principle in multivariable calculus is that these two concepts are fundamentally linked. The gradient is always parallel to the normal vector, meaning both reliably point directly away from the surface. Different types of surfaces exhibit unique geometric behaviors based on their underlying mathematical structure, dictating how that orientation changes across space. The flat plane. This represents the simplest form, where the orientation remains constant across the entire surface. Because the surface never bends, the normal vector points in the same direction regardless of where you are standing. The paraboloid. This shape creates a bowl-like structure where the surface curves upward. Because of this curvature, the direction pointing straight away from the surface is not fixed. Instead, it shifts and changes its angle as you move from the center toward the edges. The corrugated surface. This surface mimics the rhythmic ridges of a wave or a textured sheet. By utilizing trigonometric functions, it creates a series of rises and falls, resulting in an orientation that oscillates back and forth in a predictable, wave-like fashion. To translate these abstract rules into a visual model, specific tools are required. In a digital environment, this begins with a coordinate grid, a mesh that acts as a floor for the calculations. Once the height of every point is determined, a skin is rendered over the grid to create the solid object. To make the orientation visible, quiver plots are used to show exactly where the gradient points, allowing us to see the mathematical direction of the shape's slope.